Hello students, hi everyone. Once again, welcome to my channel Competitive Maths by Balaji. Today we are going to part 3 of exponents and powers. Okay, is about laws of exponents. Laws of exponents, that is third law of exponents. For any non-zero integer a into b whole power n equal to a power n into b power n, where m comma n are integers. Let us see the proof of this law. Okay, yes. Consider LHS left hand side, that is a into b whole to the power n. By the definition of exponents, we know that a power n, that means a occurs n times in the product. A occurs n times in the product. So AB whole power n can be written as AB into AB into AB into dash 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 into AB. That is A into B occurs n times in the product. Okay. Yes. This expression can be rearranged as A into A into A into dash 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 into A n times into B into B into B into dash 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 into B n times. Since multiplication is commutative, we can arrange this expression as follows: A into A into A, that is A occurs n times in the product into B occurs n times in the product. Again, by the definition of exponents, A occurs n times in the product can be written as A power n into B occurs n times in the product can be written as B power n, which is equal to what? RHS. Therefore, LHS is equal to what? RHS. That is, LHS is A into B whole to the power n is equal to A power n into B to the power n. For example, two into 5 whole power 3 can be written as 2 power 3 into 5 power 3 by using this formula. Okay, yes. Next, fourth law of exponent. Let us see the proof of this one. A by B whole power n equal A power n over B power n, where B must be not equal to 0. Yes, consider LHS, which is equal to A by B whole power n. By the definition of exponents, A power n can be written as A into A into A into dash dash and so on into A n times. So, in a similar manner, this can be written as A by B into A by B into A by B into and so on into A by B. That is, the base A by B occurs n times in the product. Now this expression can be rearranged as A into A into A into dash 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 into A n times, that is A occurs n times in the product into 1 by B into 1 by B into dash 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 into 1 by B. That is 1 by B occurs n times in the product. Since multiplication is commutative, we can rearrange this expression as follows. Okay, yes. Again, by the definition of exponents, A occurs n times in the product can be written as A power n into 1 by B occurs n times in the product, so it can be written as 1 by B whole power n. Since we know that 1 is raised to any power gives us 1. So, A power n into 1 power n is 1 by B power n. Yes. A power n into 1. A power n by B power n. So which is RHS. Therefore, LHS is equal to what? RHS. That is A by B whole power n equal to A power n by B power n. Let us see example. 2 by 7 whole power 4 equal to 2 raised to the power 4 by 7 raised to the power 4. Okay. Next law of exponent, fifth one. For any integer a, we have a power n by a power m equal to a power n minus m if n is greater than m, which is equal to 1 if n equal to m. And the value of expression is equal to 1 by a power m minus m if n is less than m. Let us see the proof. First case. If n is greater than m, then we have to prove a power n by a power m equal to a power n minus m. Okay? Yes. Since n can be written as m plus n minus m. If minus m plus m gets cancelled, we get again n. So n can be written as m plus n minus m. Now consider LHS. LHS is a power n over a power m. But n can be expressed as m plus n minus m. So substitute n value, that is n can be rearranged as m plus n minus m over a power m. But we know that first law of exponents, a power n into a power m equal to a power n plus m. That is, when the bases are equal and in between them is multiplication symbol, then power should be added. See here power are added by using first law of exponent. Numerator can be written as a power m into a power n minus m. Okay, that is a power n plus m can be written as a power n into a power m. In the same manner, a power m plus n minus m can be rearranged as a power m into a power n minus m over a power m. Okay, yes, a power m gets cancelled. A power n minus m, which is our RHS. That is, therefore, if n is greater than m, a power n by a power m equal to a power n minus m. Next, second proof. That is, if n is equal to m, if n equal to m, then a power n by a power m equal to expression value equal to 1. Proof. Consider LHS a power n by a to the power m. Since here given that n is equal to m, so a power n can be written as a power m. Since n equal to what? M. That's it. So equal terms in the numerator and denominator gets cancelled. We get 1, which is equal to what? RHS. That is, LHS equal to what? RHS. That is, if n is equal to m, a power n or a power m expression value equal to 1. Next third case, case 3. That is, if n is less than m, then expression value a power n by a power m is equal to 1 by a power m minus m. Let us provide proof. Since n is less than m, that means m is greater than n. So m can be written as n plus m minus n. M can be expressed as n plus m minus n. That is, consider LHS now. LHS equal to a power n by a power m, which is equal to a power n by, since m can be rearranged as n plus m minus m, so substitute m value, that is a power n plus m minus n. We have a power n plus m minus n. By using first law of exponents, this can be expressed as a power n over a power n into a power m minus n. That equal a power n gets cancelled. We get 1 by a power m minus n, which is equal to RHS. That is, if n is less than m, then a power n over a power m equal to 1 by a power m minus n. Okay, let us consider examples. First one, 2 power 5 over 2 cube equal dash. Second one, 2 cube over 2 cube equal dash. Third one, 2 cube over 2 power 5 equal dash. The value of the expression a power n by a power m depends on n and m. If n is greater than m, or both are equal, or n is less than m. It is of the form a power n over a power m. And if n is greater than m, we use first case, which is equal, since 5 is greater than 3, this will be equal to 2 power 5 minus 3. That means, if 5 is greater than 3, that is, n is greater than m, then consider the difference of exponents, that is, 2 power 5 minus 3 is 2 square, which is equal to 4. See here, the exponent both are equal, so its value becomes 1. If n equal to m, then a power n by a power m equal to what? 1. And here m is greater than n, so consider the difference of exponents 5 minus 3, that is 1 by 2 square, that is 1 by 4 is the answer. Next law of exponents, sixth one, a power n by m equal to mth root of a power n. Let us see the proof. Consider LHS, that is a power n by m. This can be written as a power 1 by m whole power n. So, by using laws of exponents, a power 1 by m occurs n times in the product, that is a power 1 by m into a power 1 by m into a power 1 by m into, and so on dash into a power 1 by m. That is, a power 1 by m occurs n times in the product. A power 1 by m, nothing but mth root of a, that is a radical form of exponent. Similarly, mth root a into mth root a, and so on dash mth root a occurs n times in the product. Since we know that root a into root b equal to under root a into b, since their radicals are equal, here also we have equal radicals, that is mth root of a. So this expression can be rearranged as mth root of a into dash into a. That is, a occurs times in the product, which is equal to mth root of a occurs n times in the product, can be written as a power n, which is equal to what? RHS. Therefore, LHS is equal to RHS. That is, a power n by m is mth root a power n. Let us see example. 3 power 5 by 4. This can be written as fourth root of 3 raised to the power 5. Okay, by using this formula. Next, we have a question or formula, that is, for any non-zero integer a, and a must be not equal to plus 1 and minus 1. If a power m equal to a power n, then show that m equal to n. Yes. Consider, let us suppose, given that a power m equal to a power n. Dividing with a power n on both sides, we get LHS is a power m, but we are dividing with a power n. We get LHS as a power m by a power n equal. RHS is a power n, and we are dividing with a power n. Since a power n gets cancelled, we get an expression value as 1. Now, a power m divided by a power n, which can be written as a power m minus n. Let us suppose here m is greater than n. Okay, that equal what? 1. A power m minus n equal 1 can be expressed as a power 0. This is possible when exponents are equal, that is m minus 1 equal to 0. Transpose minus n to RHS, we get m equal to n. That is, we can conclude that if a power m equal to a power n, then the exponents are also equal, m equal to n. That is, both sides, if bases are equal, then power should be equal. Okay. Let us see example problems based on these laws of exponents. Okay student, let us see the example problems based on laws of exponents. Okay. Example 1. Find the value of 5 power minus 2, 1 by 2 power minus 5, minus 5 to the power 2. Consider first one, that is, we are given 5 power minus 2. Since a power minus n is equal to 1 by a power n, by using 8th formula, similarly 5 power minus 2 is equal to 1 by 5 power 2. That equal to, in the denominator, 5 is raised to the power 2. By the definition of exponents, 5 occurs 2 times in the product. 5 occurs 2 times in the product. 1 by 5 5s are 25. Okay. Second one. Find the value of 1 by 2 power minus 5. Since we know that by 8th formula, since 1 by a power minus m equaled a power m, in a similar manner 1 by 2 power minus 5 is equal to what? 2 power 5. That is, 2 occurs 5 times in the product. That equals 2 into 2 into 2 into 2 into 2. 2 occurs 5 times in the product, which is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. That is, value of 1 by 2 power minus 5 equal to what? 32. And third one, minus 5 raised to the power 2. By the definition of exponents, the base minus 5 occurs 2 times in the product. That can be expressed as minus 5 into minus 5. Minus 5 into minus 5. Negativity of negative is positive. That is, minus into minus is plus. 5 5s are 25. So answer is plus 25. Okay. Next, example 2. Simplify the following. First one, minus 5 raised to the power 4 into minus 5 raised to the power 6. Since we know that a power m into a power n, that is, when bases are equal, in between them is multiplication symbol, then power should be added. That is, a power m plus n. In a similar manner, minus 5 raised to the power 4 into minus 5 raised to the power minus 6, which is equal to minus 5 power 4 plus of minus 6. 4 plus of minus 6. That is, we have 4 girls, 6 boys. Boys are denoted by negative, girls are denoted by positive. So, 2 boys are excess, that can be written as minus 5 power. Since the boys are excess, we write negative symbol. Minus 5 power minus 2. Or other words, 4 plus of minus 6, that is equal to minus 2. Since we know that a power minus n equal to 1 by a power n. By using this formula, this can be expressed as 1 by minus 5 power 2. That is, the exponent gets positive symbol. Again, 1 by, what is the practical meaning of minus 5 power 2? In the denominator, minus 5 occurs 2 times in the product. That is, minus 5 into minus 5. 1 by minus of minus is plus, 5 5s are 25. So answer is 1 by 25. Second question. Simplify 4 power 7 over 4 power 4. Since we know that a power n over a power m equal to, if n is greater than m, then a power n by a power m is equal to a power n minus m. That is the difference of these two exponents. Since 7 is greater than 4, since 7 is greater than 4, 4 power 7 divided by 4 power 4 equal to 4 power difference of exponents 7 minus 4, that is equal to 4 power 7 minus 4 is 3, which is equal to 4 occurs 3 times in the product. 4 occurs 3 times in the product. 4 4s are 16, 16 4s are 64. Okay, yes. Solution to third one. 3 power 5 over 3 power 3 whole to the power 5 into 3 power minus 6. Simplify the given expression. First of all, consider the inner expression, that is 3 power 5 over 3 power 3. Since 5 is greater than 3, 5 is greater than 3, we use this first formula, which can be written as 3 power, consider the difference of exponents 5 minus 3, that is 3 power 5 minus 3 is 2. Now consider whole expression, that is 3 power 5 over 3 power 3 whole to the power of 5 into 3 to the power minus 6 equal to. So the value of inner expression is 3 square. Substitute instead of this expression as 3 square whole to the power 5 into 3 power minus 6. Since it is of the form a power m whole power n, a power m whole power n equal a power m into n, we multiply the both exponents, that is 3 power 2 5s are 10 into 3 power minus 6. Since within the brackets a power m whole power n equal to a power m into n. Okay. And also we know that a power m into a power n equal to a power m plus n. Yes, a power m into a power n equal to a to the power m plus n. By using this formula, we get that bases are equal, bases are equal. In between them is multiply symbol. Then power should be added. That is equal to 3 power 10 plus of minus 6. We know that 10 plus of minus 6, that is equal to what? 4. That is, answer is 3 power 4. That means 3 occurs 4 times in the product. Can be written as 3 into 3 into 3. That is 3 3s are 9, 9 3s are 27, 27 3s are 81. Okay, students, this completes the part 3 of exponents and powers. Thank you. Have a nice day.